Okay, this is a simple website that I made called RSA Encryption and its role in online communication. I wanted to make this because I was interested in the way that RSA encryption worked, and I thought that this small website built up on React and using React Router DOM for client-side routing sort of shows how it works. So I have a little backstory here of how RSA encryption actually came about. From here we have the more in-depth mathematical explanation, but it basically goes into explain how it was discovered that by taking a number and raising it to a certain specific power, and then modulating it by a number n, we can encrypt it in such a manner that if we then raise that resultant number to a power d and modulate it by n, we will get the original number. What's useful about this is that this number here, e, and this number n, can be made public, such that anyone can take a message and do this mathematical function of raised to e modulate by n, and that will create something that even though e and n have been made public, it is unable to determine what number d should be unless you were involved in the actual calculating of these three numbers. And this goes into more detail, but the reason that this is very useful is because in order to create these three numbers, what we need to do is make a very large composite number, which is a number that consists of two primes as its factors. And the fact that it's very, very difficult to calculate the components, the primes, that make up a composite number, it means that this encryption is very effective. So while any given computer could crack this encryption, it would just take an unreasonable amount of time to do so. Many, 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 many years. So in this example, this is what I'm using as the D value here. So everything that is going to be calculated is going to be using a constant E value, and it is going to be using this as the secret D value. This is, of course, not how you would want to implement this on a website, but for the sake of showing how it works, we can do so. So what these are is everybody who has put in a word in the past. So let's say we just want someone who's called guest. Oops, caps lock. Guest. And let's say that their message here is dog. I kept the amount of letters down to 4 because some of these turn into very large numbers, and under the hood, these are being converted to a binary string before the encryption is being applied, and then it's being saved inside of my JSON server on the back end. Or simulating a backend, this number here, which is the encrypted form. And when I save it, it should get added here. Anything you put here won't register anything until it gets high enough, but at this point, what it's trying to do is decipher the code that has been entered by using this number as the D value, and as you can see, it's quite challenging to actually make that work by guessing. I think that would take quite a long time. So if you come down here, though, and grab this and place it into the lab output, you can actually see what all the words were that everybody had put in. So this is just a cool little educational tool, and back here there's handy widgets. For instance, this modular multiplicative inverse calculator was very helpful in making sure that my actual numbers were working out fine. So yeah, this was just my cool little intro to what RSA encryption is and how it works and why it's really interesting that most of the information can be published in a newspaper, but you still can't crack it. All right, thank you for tuning in.